Yo, Chuck.
What the Chuck is up, YouTube? In this video, we're going to be going over Leetcode 128, longest consecutive sequence. So a consecutive sequence is just a sequence of numbers that are in ascending order, and they're only separated by a value of 1 each. Okay, so if I have this sequence of 1, 2, 3, 4, 5, I would expect to return 5 is my answer. And we're initially given these numbers unsorted, but we're allowed to sort them if we want. They're not always going to be in ascending order from the default, so that's a possible solution, sorting. And the problem asks us to solve the algorithm in O of n time. Okay, so I'm going to show you some solutions to do that. Also, it's worth mentioning, when you get a sequence of numbers, just like we have here, and let's say we have a duplicate 2 in the middle of this sequence, this is still going to be expected to return 5 because the sequence is going to go like this. 1, 2, oh, 2 is a duplicate, we're going to skip that, 3, 4, 5, and then we're going to return 5. Okay, so I've said a bunch, let's hop over to the code. Alright, so for my first solution, you can see I've just copy and pasted the function from the Leetcode page, and I'm passing in that first test case where we have a bunch of unsorted numbers, and I want to find the longest consecutive sequence. So the first thing I'm thinking is, why don't we just sort these numbers? So I'm going to call the sort method that's built into JavaScript, pass A and B, use the arrow function and say A minus B. This will sort my numbers in ascending order. So let's return these numbers now. Okay, if I return that and run the code, now I have these numbers in ascending order. And you can easily see that we would be expected to return 4 as our answer right here, okay? And that's what it's telling us in the problem statement. All right. So just to get rid of duplicates, because if I was to, let's say, add a duplicate 1 here, you can see that's going to kind of screw up my counting of consecutive numbers. So what I'm actually going to do is make nums into a set. So I will pass in the new set keyword here, and if I return nums now, you can see it's in a set form. But I actually want to convert it back to an array. And recall, a set just will remove duplicate values so that duplicate 1 is no longer there. Okay, so we can actually do a little trickery here and convert this set into an array using the spread operator, and then we can just wrap our set we've created in brackets. So now if I was to return nums, you can see we've gotten rid of that extra 1, but we're also back to an array format. So this is nice because now I don't have to worry about duplicates. Okay, so back to the code. I'm going to run a for loop and basically count if the number is greater. So I'm going to say for let I equal 1. The idea here being that we're going to start with a count of 1, right? So that's going to be the count of how many ascending numbers we have, or how many consecutive numbers. We're initially going to start with 1 because I'm going to count this number at index 0 is 1, and then it's going to start here on my for loop at index 1, okay? Then I'm going to say I is less than nums.length, increment I. Cool. So like I said, we're going to compare values, adjacent values. So I'll say if nums at I, and recall we start at 1, I starts at 1, is greater than nums at I minus 1. So they must be greater. But also recall that, let's say if nums at index I initially is 200 and nums at index I minus 1 is 1, these two are greater, but they're not consecutive. So to make sure that I test for consecutive numbers, I'm going to say and math.absolute value of nums I minus nums I minus 1. And then I want that to be equal to 1, okay? So if those conditions are true, I can increment my count. And now I need to make a variable to store my count because I want to get the max count possible. So let's make a variable called max. Initially, I'm going to set that to -infinity. Okay, or actually I could just set it to 1. That probably would make more sense because we're always going to have a count of 1 for our initial max no matter what, because at least one number would be a count of 1, right? Okay, so every time we run this code and increment count, I want to check that with max. I'm going to say max equals math.max, which is going to take arguments. I'm going to pass in the max variable and then also count. What this will do is update my max variable to be the largest of whatever these two variables are. Okay, so that is our test case to increment for a consecutive sequence. What happens if these numbers aren't in a sequence? Then I want to do an else statement and set count back to 1, okay? So now if I was to return max, let's see what happens here. We get 4, and that looks pretty good. I might need to do some edge cases, so I might say like if nums.length equals 0, return 0, because I'm initially setting count to 1, so I don't want them to do anything tricky. Okay, this looks pretty good. Let's return this code and see if it works. Running the code in Leetcode here, submit, and that looks like it works. Pretty acceptable solution. If we go back, we can see this is time complexity of linear time, or O of n, which was part of the description problem statement. Yeah, it says write an algorithm that runs in linear time. Perfect. Okay, so notice we did use a set here, and then we did sort. I'm going to show you a solution now that does not use set, that's a little bit faster. All right, so if I want to solve this without using a set, let's first just delete the set that we created. And now I'm going to return nums. And if I do that, all right, you can see I'm returning that array of numbers, and I have duplicate values, right? So we don't actually need to make a set because we can just do some if-else logic that will basically fix the problem. So instead of saying just else count equals 1, I'm going to say else if nums at I equals nums at I minus 1. Then I just want to continue. And what this is going to do is whenever the numbers are equal, say for instance 1 and 1, it's just going to go to the next iteration of the loop and not even do anything else. So now if I run this logic, let's save it here. If I run this, let's see what happens. We get 4 again. Now let's try to do this in Leetcode. Run this guy. And look at that, it's much faster than the last one. We're not having to use additional memory. Look at that memory saved, 52 megabytes versus 64 by making that new set. So now we're not making a set. We're just being a little bit smarter and optimizing our code. So this is a very good solution. Now I want to show you a solution that doesn't even rely on sorting, because this problem would be a lot harder if we couldn't sort, because then the numbers would not be in ascending order. So let's try that solution right now. All right, so to solve this without sorting, I'm going to first delete all the code we just wrote, and then make a set using the new set keyword, pass in our numbers, and let's return that real fast. Node test. Okay, so you can see we've got a set of all of our numbers. Notice the duplicate 1 is gone. Great. So I also want to make a count variable like before. This time I'm going to initialize it as 0. It really doesn't matter what its value is right here. And then I'm also going to make a max variable, which we already discussed should always at the bare minimum be 1, because if we're doing a sequence of numbers, if there is no sequence at all, we would at least have a sequence of length 1. Okay? So I'm going to do a similar thing we did before. I'm going to make a for loop. This time I'm setting index I. I'm starting it at 0. And then I'm going to say while I is less than nums.length, increment I. Now I need to check my set, because my set is all those numbers that I just put in there. And I need to basically find the start of sequences. So the way I'm going to do that is I'm going to use an if statement and say if set has nums at I minus 1, and I'm using the not operator here, so I'm saying if there is no nums at I minus 1, then I know I'm at the beginning of my sequence. So for instance here, this would only be triggered, this if statement would only be triggered if I was on that 1 for the sequence of 1, 2, 3, 4. If I was over a 2, for instance, it wouldn't be triggered because there is a set, my set does have nums at I minus 1, which would be 1, so it wouldn't fire. Okay, so that's the logic there. If that is true, I'm going to set count equal to 0 because I'm going to count how many numbers there are in the sequence. So I'm going to use a while loop here and say while set has nums at I plus count. And this is kind of sneaky because count is going to increment. So every time count increments, I'm going to basically increment my number that I'm looking for in the has method. So if I have number 1, now my count is going to equal 1. And then because my count is equal to 1, my next number will be numsI plus whatever count was, which is going to be 1 plus 1, because my count is 1, and that's going to equal 2. And then also, I'm going to do the same thing. I'm going to say, what's my count now? My count is 2, so I'm going to have 3, and it's going to keep going and increasing just like that. Okay? So that's really sneaky. I'm going to say count plus plus, and then every time we increment the count, we want to check, or I guess we should say, when we increment the count, we want to check it against max. So I'll say max equals math.max, and then pass in max and count just like before. And I'm going to return max, obviously. If I run this code, I get 4. So the main thing that's tricky here is, I think, this not operator. And why are we checking for a number 1 less than the current number we're on? Well, that's because we want to find where the sequence starts, the correct number the sequence starts. When we've reached that correct number, now we can do this while loop and basically increment by 1 each time, okay? And that's going to give us the accurate sequence length. So let's run this in Leetcode, pass in this code, and it looks like, oh, we need a edge case, so let's not forget our edge case. If nums.length equals 0, just return 0. Okay, run the code again, and it works. But notice this is going to be much slower, because every time we run this for loop, if we find a number that's the beginning of a sequence, we're going to have to run a while loop and then increment that count. So it's kind of performatively slow. So that's why it was easier to do this when we could just sort the array, right? But this is a cool example of not even using sorting and then also using a set. So there you have it. If you found this video valuable, please like and subscribe, and I will see you guys in the next one.